Welcome to the Explainer. So, let's dive right into this incredibly fascinating GitHub repo that solves a massive, and I mean literally massive problem in modern AI development. Today, we're looking at the Agentic Data Worker. It's an asynchronous, AI-assisted data analysis backend by Mikkel Konwiak. If you've ever tried building an AI app that touches your raw data and, found yourself terrified it might accidentally drop a table or hallucinate some destructive command, well, you're in exactly the right place. This project is basically a masterclass blueprint for building AI pipelines that are genuinely safe, structured, and reliable.
Here's our roadmap for today. We're going to hit the AI trust problem, check out the agentic approach, walk through the step-by-step data flow, look at the safety sandbox, and finish up with some really smart design decisions.
All right, part 1, the AI trust problem and why models break. Let's address the elephant in the room when it comes to building AI-powered tools today. The project's documentation absolutely hits the nail on the head here. LLM applications often fail because the model is allowed to do too much. This right here is the foundational thesis of the entire Agentic Data Worker project. It perfectly highlights that handing models unchecked execution power, it's a total recipe for disaster. I mean, we've all seen those demos, right? You just plug an LLM straight into a database, let it run wild. Works flawlessly for a 5-minute Twitter video, but in production, oh boy. It hallucinates, it runs crazy inefficient queries, or worse, tries to execute destructive operations. The core issue is we're trusting a probabilistic model to do deterministic, high-stakes work completely unsupervised.
Moving to part 2, the agentic approach, or as I like to think of it, the architect versus the builder.
This approach totally shifts the paradigm of AI responsibility. So the flawed approach is letting the LLM generate and directly execute the SQL. But the agentic approach flips the script. The LLM is strictly the planner. The backend stays completely in charge of validation, execution, persistence, the whole shebang. Think of it like building a house. The AI is the architect drawing up the blueprints, which in this case is our SQL query. But the AI is never ever allowed to pick up a hammer. The backend is the builder. It takes those blueprints, double-checks them against the building code, and does the actual swinging.
To enforce this strict architect role, the project leans on a framework called Pydantic AI. Why does this matter? Well, normally, an LLM just spits out unpredictable free-form text. You might get a clean query, or you might get a query wrapped in a whole chatty paragraph saying, "Here's your SQL code, human," right? Pydantic AI guarantees the LLM outputs strict typed plans. It literally forces the AI into a rigid data contract. Because we're getting a structured model instead of just a wall of text, the backend can actually parse it, understand it, and reliably validate exactly what the AI is trying to do.
Okay, Section 3, Step-by-Step Data Flow. Let's look at the actual mechanics of what happens when you upload a dataset.
First things first, data analysis takes time. You can't just throw a complex question about a massive CSV file at an AI and expect your HTTP API to bounce back in 200 milliseconds. If you try that, your API is just going to hang and time out. So the system brilliantly integrates Temporal. Temporal is a platform that spins up asynchronous workflow executions. It reliably handles these long-running analysis jobs in the background, which keeps your API snappy and responsive while the AI and the database are, doing all the heavy lifting behind the scenes.
Let's walk through this incredibly elegant 6-step journey. Step 1, you upload a CSV, and the system profiles the schema. 2, you create an analysis job with a natural language question. Maybe something like, what's our total revenue by category? Step 3, that temporal workflow kicks in and the AI generates a structured analysis plan. 4, and this is really where the magic happens, the backend intercepts and strictly validates the generated SQL. Step 5, the database executes that safe, read-only SQL against your CSV. And finally, Step 6, it stores the results and whips up a clean Markdown report. I want to zoom in on Steps 4 and 5 for a second, because this is honestly the beating heart of the system. Two highly specialized tools step up to the plate here, SQLglot and DuckDB. SQLglot is basically acting as that strict building inspector we talked about. It parses the AI-generated SQL to ensure it breaks absolutely zero rules. Once it gets the green light, DuckDB revs up. And DuckDB is phenomenal for this because it performs crazy fast local analytical execution directly over the CSV files you uploaded. There's no need to shunt your data into some massive cloud data warehouse. It just queries the file locally, which is unbelievably efficient.
Section 4, the safety sandbox and how we lock down execution. The golden rule here? AI output is strictly treated as untrusted.
To enforce that rule, the backend builds an absolute fortress of a sandbox.
Check out these restrictions enforced by SQLglot. Only a single SQL statement is allowed, so the AI can't try and sneak in multiple commands. We're talking read-only select queries only. Destructive operations like an update or a drop table? Outright rejected. Goodbye 2 a.m. production nightmares. Plus, the AI is restricted to querying one single virtual table, literally named dataset. Any attempt to access external tables is completely blocked. And to top it off, query results are truncated to a set maximum row count so you don't blow up your memory. The AI is completely fenced in. It can look at the data you handed it, and that is it. It simply cannot break your system.
Finally, Section 5, Smart Design Decisions, and our final takeaways from the explainer.
All of that complex, highly secure backend architecture ultimately distills down to these beautifully clean, first-class artifacts. When the workflow wraps up, you don't just get some raw database dump, you get structured, stored API objects. For example, you get this really clean markdown report answering that query about electronics revenue, complete with helpful metadata, like how many rows were returned and whether or not the data had to be truncated. By making these results first-class API objects, consumers can easily inspect the job steps and pull those generated outputs whenever they need them.
So, what are the big takeaways from the Agentic Data Worker? Well, these core principles are practically a masterclass in building robust AI apps. 1. Force your LLM to output structured, typed models. 2. Never ever let the AI execute SQL itself. Strictly control it from the backend. 3. Use tools like Temporal to handle your async, long-running work. 4. Treat your outputs as permanent, queryable artifacts. And 5. This is huge for you developers out there. Because the AI is just a planner outputting structured data, this entire system is highly testable without even making real AI calls. You can just plug in fake planners to test your backend logic deterministically, saving a ton of time and API costs.
As we wrap up this explainer, I want to leave you with one critical question to ask yourself about your own architecture. Are your AI models doing too much? Are you accidentally letting the architect swing the hammer? Take a page out of the Agentic Data Worker playbook. Lock down your execution environment and start building AI pipelines that you can actually trust in production. Thanks so much for joining me on this deep dive, and I'll catch you on the next one.